Hey guys, welcome to part 2 of solving rational expressions and equations. We are just going to jump right in. So yesterday we talked about how you must check your answers and that we do not want a zero in the denominator. So like for instance, if I got an x x equals 2 here, that would actually be extraneous because if I plug 2 in here, that would give me a 0 in the denominator. So 0 on top is okay, 0 on bottom is no way. So we cannot have a 0 in the denominator. So this would be false. Over here, if I plug in 2 here, that would be over 4, totally okay. If I plug in 2 here, it's going to be over 6, totally okay. This doesn't even have a denominator, so 2 is a totally fine solution for that. So that's how those extraneous solutions work. So we're just going to be kind of keeping our eye out. We did these two problems yesterday, or similar problems yesterday. So I'm going to work through those really quickly so we can jump into the more difficult stuff. Okay, so these are our answers for both of these. And again, they're just a total review from yesterday. So let's go ahead and get into the new stuff. Okay, so these are the steps that we're going to use to solve a rational equation. One of the first things is we're going to have to factor. So make sure you're factoring the denominators, and then you are going to have to find the least common denominator. And we are going to multiply everything by that least common denominator. And then we're going to basically just do what we can to carry on with the problem. So let's kind of look at the problem, if I can find it. Okay, so we have this. So notice that before these would have been the same, but now they're different. So we're going to have to do our new steps. So the first thing is to factor, which we don't need to. And then our next thing is to find the LCD. So what is the LCD of 7 and x? Okay, so it should be 7x. And so what we're going to do is we're going to multiply everything by 7x over 1. 7x over 1, 7x over 1. Okay, and I'm going to cancel where I can. So in this case, the 7's cancel out, and I'm left with 3x. Here, the x's cancel out, and so I'm left with 7 times 8, which is 56. And here, nothing cancels out, so it's going to be 7x. And then from here, it's pretty easy. We're just going to combine like terms. And solve for x. Okay, so I'm going to clean this up over here, and let's see if 14 is okay. And it is totally okay because that is not going to give us a 0 in the denominator. Okay, so let's go to the next one. So we're going to multiply everything through by our common denominator. Actually, this one, notice that if I take this and combine like terms, I can kind of make this problem a little bit easier. So I'm going to go ahead and do that. Kind of be on the lookout for that. So I'm going to subtract this fraction right here. And notice how the denominators are the same. So I'm going to have 5x minus 10 on top over x minus 2. And then equals 7 over 1. And go ahead and cross multiply and see what you get. Okay, so I end up getting x equals 2. So this is my first extraneous solution I found because when I plug in 2, I'm going to get a 0 in the denominator in both places, here and here. And so this is actually no solution. Okay, and so this is the same way. I think what I'm going to do is I'm going to combine those two and see what I. And so now I'm combining just my regular numbers. So 1.5 minus 1 is 1/2. And then I can cross multiply. So I'm going to cross multiply here and here. So x equals. And if I look in the denominators, we are okay. 6 is totally okay in the denominator. Now notice this one I can't really do anything with, so I'm going to have to find the LCD and kind of go from there. So my LCD, let's factor first. So this is the first time we've had a factor, and so it's just going to be x times x minus 2. This is one piece, this is the other, this is both pieces. So that's going to be our LCD. So I'm going to multiply everything by x times x minus 2. So what happens is these cancel, and I'm left with 3 times x minus 2. X times x minus 2, and these cancel, and so I'm left with plus 6x. And then notice that everything is part of the LCD, so everything cancels out, and I'm left with 12 for the last term. So from here, I'm just going to clean it up. So 9x minus 6, 9x equals 18, x equals 2. So again, that 2 is sticking out because, let me erase this. So right there. So this is another example of no solution. Okay, so we have 2 more. So our first step is to factor and find the LCD. So this is x minus 3, x plus 3, and that ends up being our LCD. So see if you can find the LCD over at this one. Okay, so it ends up being kind of the same concept. So when I factor this, it's both pieces. So I get 2x minus 1 times 2x plus 1. So that's what I'm going to multiply everything by, is x minus 3, x plus 3. And see if you can figure out what cancels. Okay, so there's a lot going on in this problem. I went from here to here for my next step. And so the last step I just distributed the 4 and I distributed the 2. That's it. Okay, and so now I'm just going to solve for x. So we're going to combine like terms. So see if you can do. Okay, so I ended up getting x equals -1, so you can kind of see my work here. I just combined like terms and solve for x. And so we're going to do the same thing here that we did in this problem. So go ahead and we have our LCD, so start multiplying and canceling out. Okay, so this was my next step. So I showed where I canceled up here, and I ended up with this equation. So now I'm just going to simplify everything. So I'm going to distribute this x and distribute the -2, and then move everything over to 0. So see if you can do that. Okay, so I ended up with x squared minus 3x minus 18 equals 0. And then I'm just going to see if I can factor that. So I can do the shortcut method. So I have 2 factors of 18 that subtract to give me 3. So if you said 6 and 3, you're correct. I want it to be negative, so -6, +3. So my answer is x equals 6 and x equals -3. And that's